Ever wondered how data travels in a computer network? It's a fascinating journey that takes place across what we call network media. These are the physical materials or channels that carry your data from one device to another. And believe me, the choice of media can make a world of difference. It can affect the speed at which your data travels, the distance it can cover, the cost of your network, and overall performance. So it's safe to say that network media are the unsung heroes of our connected world. We can broadly categorize these heroes into three types: guided or wired media, wireless media, and optical media. Each of these has its own set of characteristics, advantages, and disadvantages. Understanding them will help you make informed decisions about your network design and performance. First, let's delve into the world of guided or wired media. Guided media, as the name suggests, guide data signals from one point to another. These physical conduits, often referred to as wired connections, play a vital role in transmitting data across networks. The first type of guided media we'll explore is the twisted pair cable. This cable is made up of pairs of insulated copper wires twisted together. It's the common choice for local area networks, like those found in many businesses. This is thanks to its cost-effectiveness and ease of installation. However, it's worth noting that while twisted pair cables are inexpensive and easy to install, they are susceptible to electromagnetic interference and can only cover a relatively short maximum length without the use of repeaters. Next, we have the coaxial cable. This cable consists of a central copper conductor surrounded by a plastic layer for insulation, a metallic foil or braided shield, and an outer plastic covering. It's the go-to choice for systems like cable television, broadband internet, and traditional Ethernet networks. Coaxial cables are less susceptible to electrical interference than twisted pair cables and can support longer distances. However, they are more expensive and less flexible. The third type of guided media is the shielded twisted pair cable, often abbreviated as STP. The structure of STP is similar to unshielded twisted pair cables, but with an added layer of shielding for extra protection against interference. This makes it better at mitigating interference and crosstalk compared to its unshielded counterpart. However, this additional shielding makes STP cables more expensive and less flexible than unshielded twisted pair cables. Each of these guided media types has its unique structure, use, advantages, and disadvantages. The choice between them often comes down to a balance of cost, performance, and the specific requirements of the network. Twisted pair cables are a great choice for cost-effective local area networks, while coaxial cables are ideal for long-distance transmissions with less interference. On the other hand, if your network is in an environment with high levels of interference, shielded twisted pair cables might be the best option. However, it's important to remember that these are not the only options available when it comes to network media. Even though guided media provide a reliable connection, they're not the only players in the game. Next up, we have wireless media. Wireless media transmit data through the air, offering mobility and flexibility. This revolution in communication has allowed us to break free from the constraints of cables, making our devices portable and our lives more convenient. Let's start with radio waves. These are the jack of all trades in the wireless world, used extensively in mobile communications, broadcast networks, and even your home Wi-Fi. They offer the advantage of covering large areas, making them versatile in use. But they're not without their drawbacks. Radio waves are prone to interference from other devices and structures, and they can be less secure, posing a potential risk to your data. Next, we have microwaves. Not the ones you use to heat up your dinner, but the ones that power point-to-point communication and satellite networks. These waves are the long-distance runners of the wireless world, capable of transmitting large amounts of data over vast distances. However, their need for a clear line of sight between relay stations and their susceptibility to environmental conditions can sometimes limit their effectiveness. Last but not least, we have infrared signals. You'll find these in your remote controls and short-range communication devices within confined areas. They're the unsung heroes of the wireless world. Inexpensive, easy to use, and perfect for close quarters. But don't expect them to do the heavy lifting. Infrared signals don't pass through solid objects and their range is limited, making them suitable for only specific applications. So, as you can see, each type of wireless media has its strengths and weaknesses. Radio waves, with their broad coverage and versatility, are great for general use. Microwaves, with their long-range capabilities, are perfect for point-to-point and satellite communication. And infrared signals, with their simplicity and affordability, are ideal for short-range confined applications. But it's not just about the type of wireless media. The frequency, power, and even the atmospheric conditions can also affect the performance of your wireless network. So it's important to understand these factors and choose the right wireless media for your specific needs. And while wireless media free us from the constraints of cables, there's another type of media that takes data transmission to the speed of light. Yes, we're talking about optical media, but that's a topic for another time. So to sum it up, wireless media offer mobility, flexibility, and the convenience of a cable-free environment. But they also come with their own set of challenges, from interference and security issues to range limitations and environmental factors. But with a little understanding and careful selection, you can harness the power of wireless media to create a network that's just right for you. So whether you're a network engineer or just a tech enthusiast, understanding the ins and outs of wireless media can open up a world of possibilities. And remember, the best network is the one that meets your needs, whether it's wired, wireless, or a combination of both. And that's the beauty of technology. It's always evolving, always pushing the boundaries, always offering new ways to connect and communicate. And in the world of networking, that means breaking free from cables and embracing the power of wireless media. Because in the end, it's all about making our lives better, easier, and more connected. While wireless media free us from the constraints of cables, there's another type of media that takes data transmission to the speed of light. Yes, we're talking about optical media. Optical media use light pulses to transmit data, achieving incredibly high speeds. At the heart of this technology lies the fiber optic cable. This cable is comprised of tiny strands of glass or plastic, each not much thicker than a human hair. These strands are bundled together, and each one carries a beam of light that represents the data being sent. The use of fiber optic cables is ideal for high-speed data transmission over long distances. It's not just about speed, though. Fiber optics are also used in backbone networks, those critical arteries of the internet that carry vast amounts of data around the world. The advantages of optical media are compelling. First, fiber optic cables provide very high bandwidth, allowing large volumes of data to be transmitted simultaneously. This makes them perfect for applications that require high data rates, such as streaming video services or cloud computing. Second, fiber optics are immune to electromagnetic interference. In contrast to traditional wired connections, which can suffer from interference from nearby electrical equipment, fiber optic cables can run alongside power lines without any impact on data transmission. Finally, compared to other forms of wired media, data loss over long distances is minimal with fiber optics. This is because light signals don't degrade as quickly as electrical signals. As a result, fiber optic cables can span great distances without the need for signal boosters. However, it's important to note that fiber optics are not without their challenges. They are more expensive and complex to install and maintain compared to other wired forms. Specialized equipment is required to install fiber optic cables, and even minor damage can severely impair their performance. Despite these challenges, the benefits of fiber optics make them a popular choice for many network applications. As technology continues to advance, we can expect to see even more widespread use of optical media. Choosing the right media for your network is crucial. It's not just about speed, but also cost, distance, and overall performance. It's a balance that requires careful consideration. So now you know how data journeys through different types of media in a computer network. We've explored the world of wired connections where guided media like the versatile twisted pair, the resilient coaxial cable, and the shielded twisted pair play their roles. We've broken free from cables with wireless media, darting through the air on radio waves, microwaves, and even infrared signals. And we've traveled at the speed of light with optical media, where fiber optic cables carry data over vast distances with minimal loss. Each type of media, with its unique strengths and limitations, contributes to the overall performance of a network. Whether it's a cost-effective local area network using unshielded twisted pair cables, a high-speed backbone network with fiber optics, or a mobile network leveraging radio waves, the choice of media is crucial. Next time you use a network, remember that there's a whole world of media making it possible. Until then, keep exploring the wonders of technology.